Okay, I see that we are just about live. Excellent. Okay, well, good morning, good afternoon, or good evening to all of you who are joining us today. I see a lot of new faces, and so this is really good. So today we are going to have a seminar by Dr. Arun Singh from the Banaras Hindu University. And I believe it's Varanasi, right? And
yeah.
Okay, excellent, excellent. So greetings to everybody joining us from there today. Just as a reminder, for those of you who are new today, if you would hold your questions till the end of the talk, and if you could type those in to the chat, so then we can all read your question, and then I will then call on you, and then you can either read out the question yourself, or then I can read the question for you. And that's how we'll do the Q&A at the end of the talk. And then if you also would like to subscribe to our kind of mailing list, just please send me an email or another one of the co-hosts, Liviu or Peter Giosan, whose contact info are all on our website. Just send us an email and we'll add you to the mailing list for announcements. So without further ado, Dr. Singh, if you would please share your screen, we can learn a little bit more about millennial scale variability in the Arabian Sea.
Thank you, Tara.
You're welcome.
So at the outset, I thank Peter, Tara, and Liviu for organizing a wonderful monsoon lecture series, which we have been, witnessing since the last Jan, and for giving me an opportunity to share my major research findings, what we have been carrying out in the recent past. If you see the global monsoon system, in fact, now the concept has been emerging that each subsystem, if you combine together, it is treated as a global monsoon system, and the global monsoon system has intimate the relationship with the oscillation, with the annual oscillation of ITCZ with the maximum displacement in the Indian Ocean. Each system of the global monsoon system has its own feature because of its peculiar topographic and geographic locations. Therefore, in order to understand the forcing mechanism of each monsoon system, one has to investigate each monsoon system in detail. Here we are focusing on the Arabian Sea monsoon system. If you see, the Arabian Sea and the Bay of Bengal are the two semi-enclosed basins forced by the seasonally reversed monsoon winds. And seasonal monsoon winds, it produces the spatial pattern in the surface hydrography, biological productivity, etc., and the vertical flux of the lithogenic flux and the biological flux. So if you see that, if you want to investigate that the seasonal dynamics of the monsoon system, then it is very imperative to investigate that the seasonality of the monsoon, how it has been evolved through time and space. The high biological productivity in the Arabian Sea and the high export flux of the organic matter, it utilizes the oxygen, dissolved oxygen in the water column, and which results in the development of the oxygen minimum zone. And this is the shaded area, what you see, it is the intensified oxygen minimum zone. Now, in recent past, there has been a lot of studies focusing mainly on the western and northern Arabian Sea. And because of the lot of the data emerging based on the multi-proxy records, we now have the better understanding how the southwest monsoon has varied in the past on various time scales. In the recent years, IODP has put its efforts uh, to drill in the Arabian Sea and the Bay of Bengal sites, and uh, in order to investigate that the evolution of the monsoon system on the various time scales. And here, here you have the IODP 355 in the Arabian Sea, in the northeastern Arabian Sea region. Then you have the recently drilled IODP 3559 in the Maldives region, and the results are coming up now, and which has provided the better insights on the long-term changes of the monsoon system. Of course, the millennial scale changes in the South Asian monsoon system has already been recognized, but it is mainly focused on the variability of the southwest summer monsoon system. But our our understanding of the seasonal dynamics of the monsoon, South Asian monsoon, in time and space is still incomplete, because we still know less about the winter monsoon variability. And for that, the Indian margin of the Arabian Sea is sensitive to both the southwest and the northeast monsoons, northeast and the southwest summer monsoon circulation, because during the southwest monsoon season you have a massive upwelling resulting the high primary productivity in the western Arabian Sea, and you also see a weak to moderate upwelling in the southwest coast of India. But when the monsoon wind reverses during the winter, the dry and cold winds, it drives the vertical convective mixing in the northeastern Arabian Sea and the northern Arabian Sea. So you have a moderate to weak productivity increase during the winter time. Therefore, what we see in the Arabian Sea, we have the bimodal pattern of the biological productivity. What we have selected, we have selected the central part of the Indian margin, because this is very sensitive to record the winter monsoon activity as well as the south monsoon activity. That the reason is that, for a simple reason, that that you have the signature of the northeast winter monsoon wind induced mixing up to the 10-degree latitude, and because of the western Ghat, you have high fluvial runoff and discharge, which creates a low salinity plume in this area. Therefore, we can record here both the variability of the southwest monsoon and the northeast monsoon season. Here you could see the data of the temperature and the mixed layer data of the WHOI, which shows very clearly that along between the 10 to 15 degree latitude along the Indian margin, that the mixed layer, it deepens up to the 100 meter. That means that you have the signature here of the winter monsoon offshore Goa at about 15-degree latitudes. And as I told you, as I have already explained you, that because of the fluvial discharge in the southwest monsoon season, you have the low salinity plume, and surface water of this area is well stratified. So you have the signature of both the southwest and the winter monsoon. So this is the ideal region. Just to understand that how the seasonal changes in the monsoon have evolved through time. Since we are focusing here on the millennial scale time scale, so that our results will be mainly focused on the millennial scale time, the changes on the millennial scale time scale. We have selected a two cores. We have selected the two salt sediment cores. These are the gravity cores. One comes from the middle part of the OMZ, and the second core, it comes from the lower part of the OMZ. So this provides us a very good opportunity just to see that how the OMZ has evolved through time in the last few thousand years. As a micropaleontologist, we have taken advantage of the different microfossil groups to understand the whole entire water column structure in response to the seasonal variability of the monsoon system, as well as just to establish its linkage with the global climatic perturbations. We have developed the expertise on the planktic foraminifera, which are very sensitive to the changes in the surface ocean conditions. We have also taken the pteropods, which have the mesopelagic habitat and very sensitive to the changes of the carbonate chemistry, being the orogenitic in composition. We have also developed expertise in the benthic foraminifera, which are very sensitive to the oxygen content at the bottom water, at the sea floor. So, and in addition to these microfossil groups, through collaboration, we have also used the records of the coccoliths and the dinoflagellate records. So by combining all these micropaleontological parameters and combined with the geochemical and isotopic proxy records, we tried to reconstruct the changes in the entire water column structure offshore Goa, and we have also compared these records across the basin just to know that how the Arabian Sea hydrography has changed through time in response to the seasonal monsoon variability as well as global ocean circulation. The proxies what we have used, as I told you that our main focus was to use that the microfossil foraminifera combined with the isotopic and the geochemical records. So we have used the planktic foraminifera and the nanoplanktons and other microfossil groups just to record the changes in the sea surface condition, and we have used here pteropods along with the nitrogen isotope of the sediments just to record the changes.
I believe that we might have lost Dr. Singh here for a moment.
I think so.
So if everyone would just, Dr. Singh is back. So I'll see if, do you still have permission, Dr. Singh, to present? Yes, you do. So
yes. There
okay.
There was some interaction. Now it's fine.
Yeah, your connection's good now.
It's okay
so
now?
yes, so if we could just reconnect your screen sharing, then I think we can just continue forth. it's amazing that we can all share a connection together across the globe, but we have to expect some global technical difficulties sometimes. Let's see.
Okay, so I'm sorry for the interruption. Of course, this is, see, this is some technical issues that what we have. So that what I would like to emphasize here, that we have taken the different proxies, that micropaleontological proxies, the isotope proxies, and the geochemical proxies, just to record the changes in the entire water column. So now I'm coming to that we have developed the different proxies. We have developed the different proxy records just to see the sea surface temperature and the salinity conditions. And this is, this is the work which I did in collaboration with the Pallavi Anand, and where we have taken the two plantiform species, Globigerina buluoides and Globigerina ruber, and then we have compared our offshore Goa core record with the Western Arabian Sea 905 record, and what we have found here, the difference of the temperature of these two species, as you must be aware that Globigerina ruber, it calcifies its test throughout the year, so it gives you the annual temperature record. And Globigerina buluoides, it is the nutrient-rich water. It flourishes in the nutrient-rich water, so it is more. It produces more during the upwelling or the winter mixing season. So what you see here in the Western Arabian Sea record, you see the difference all through, from the last glacial maximum throughout the Holocene. That means that there has been the seasonal changes all through the time from the LGM to the Holocene in the Western Arabian Sea. But here in the Eastern Arabian Sea offshore Goa, what we found that the maximum, the seasonality developed during the last glacial maximum, and this could be probably attributed to the intensification of the winter monsoon, and then from the last glacial maximum, after the last glacial maximum, across the deglacial period, you have the abrupt warming events, and the younger dryas events, you have the warming of the surface water. That could be attributed to that it might have some link to the tropical, it might have the tropical region origin. Then if you see the salinity variation here, the salinity variation, of course, it is quite obvious that in offshore Goa, you have the high amplitude of the variation of the salinity shown by both the ruber and the buluoides records, which you don't see in the Western, which you don't find in the Western Arabian Sea. It is quite obvious that the fluvial discharge during the southwest monsoon is much and more in the Eastern Arabian Sea because we have here the western part, and we have here many rivers which brings the fluvial waters to the sea. If you compare, we have compared the records from the Indian margin from pattern of the sea surface temperature. Overall pattern, it looks similar, except the southernmost, which has a little bit the low resolution record. But what the interesting point you can find it here, that during last glacial maximum in the southernmost core, which comes around the 6-degree latitudes, here the LGM is relatively warmer than the other core sites. So this means that as you go from the north toward the south across the Indian margin, the influence of the winter monsoon is declined. Now, if you see the temperature record here I would like to impress upon you that the role of the northeast monsoon and the temperature variation across the basin. Here you have the two codes, SO 9093 KL and 2354. These two sites situated in the northern Arabian Sea. They both sites are influenced by the winter monsoon activity, but this the 234, you also have the southwesterly winds induced massive upwelling, and this could be very well reflected here that you have the maximum the upwelling, the minimum the low temperature in the Holocene, and that is the period of the early Holocene, the maxima that where you have the maximum southwest monsoon. But then again, the shaded area, what you see that reflects the upwelling, the southwest monsoon induced upwelling. But here the interesting point is that just during the interstadials, you have the intensification, you have the weakening of the northeast monsoon season. Weakening of the northeast monsoon season, because here you see the warming episode. If you come to our southern coast, offshore Goa and 905, here what you find here that during the last glacial monsoon, the both the core records, it shows the minimum temperature by 2 to 4 degrees Celsius lower than the Holocene, and then during the early Holocene you don't see the southwest monsoon maximum which you have seen of Oman. This could be attributed to the northward shift of the later jet. What I perceive that during the Holocene, because of the shifting of the northward shifting of the later jet from the Somali margin to the Oman margin, you have the maximum, the southwest monsoon upwelling signature at the 905. Now I am coming to the productivity chain. As I told you that the Arabian Sea, you have the Arabian Sea is high productive basin, and most of the productivity is related with the southwest monsoon upwelling, and of course you also have the moderate vertical mixing induced productivity increase. So Globigerina boulevardiensis is very well established proxy for the upwelling, and many workers, in fact, they have been using the Globigerina boulevardiensis as the upwelling indicator and as an indicator of the monsoon wind intensity. Here we have compared our Globigerina boulevardiensis record of the offshore Goa with the Oman margin and the Somali margin. And what we find that the variation pattern, temporal variation pattern of Somalia and Oman looks very similar, because it is more, because both the areas are influenced by the southwest monsoon upwelling, but there is heterogeneity if you compare with the offshore record of the Goa of the Globigerina boulevardiensis. Globigerina boulevardiensis offshore Goa, we have in a substantial amount, that is up to 20 to 24% of the Globigerina boulevardiensis, which cannot be explained by the southwest monsoon induced upwelling in our area offshore Goa. This could be related with that either the Globigerina boulevardiensis is related with the vertical mixing induced by the winter monsoon, or there is a possibility some of the workers, they propagate that there is some moderate to weak upwelling during the summer monsoon season offshore Goa. Recent studies by the what this group has found that there are two kinds of the boloides in the Arabian Sea. One is related with the cool water, that is the type 2 boloides, warm water boloides. And if you see the isotopic the signatures of the SK17 offshore Goa and 905 the Western Arabian Sea, the Somali margin, it is very well reflected that the boloides what we have in offshore Goa that secretes the cell ranging between offshore Somalia, it secretes its cell much deeper up to the 700 meters. That means that here in the night you have the majority of the boloides, the cool boloides could relate the warm water boloides, and that could be attributed to the vertical mixing and or upwelling. In order to have a better interpretation, just to see the changes in the mixed layer condition and the nutrient condition of the mixed layer, we have clubbed all the eutrophic species of the mixed layer, that is the Globigerina boloides, Globigerina glutinata, and the Falconensis, and then we have compared this record with other productive and here we find the very interesting results that on the orbital scales, both the Eastern Arabian Sea and Western Arabian Sea records are showing the opposite pattern, but these orbital scale oscillations are superimposed by centennial to millennial scale oscillations, which are in concern with the Greenland ice core records. And what is the interesting find here is that during the cold stadial periods, during the Henrich periods, you have the productivity lows in the Western Arabian Sea and Eastern Arabian Sea both. So that means that, but at this stage, it will be very difficult we find it very difficult to explain that why this the behavior, the synchronous behavior of the productivity lows during the stadial time between the Western and the Eastern Arabian Sea, and when the northeasterly winds and the southeasterly winds both they are weakened. The one possible reason in our paper, which was published in Paleoceanography in 2011, we propagated that during the cold stadial periods, because of the intensification of the westerly winds, that has weakened the propagation of the northerly and northeasterly winds, and this is why we see here the low productivity, northeast monsoon induced low productivity in the Eastern Arabian Sea. In order to strengthen our record, we have also used the Popolithophore records as well as other proxy records also. But what we find here, a divergence in nature of the responses of the Popolithophore with the Planktic foraminiferous record. Here, if you compare the record of the magnesium calcium derived temperature record and the salinity record, here the magnesium calcium term record, it goes very well with the rapid switch during the deglacial time, and you have the low productivity during the Henrich events and during the younger Drake events. But if you see the Propolis-4 proxy records, it doesn't show that kind of the variation on the millennial scale. This is really quite intriguing, and it needs to be further investigated. In order, then we have also included the dinoflagellate, calcareous dinoflagellate cyst record, also cyst record, and there that our organic productivity record, it goes to cyst record. So that means our planktic foraminifera and dinoflagellate cyst record goes very well with the magnesium calcium derived temperature record. Somehow the ecology of the Propolis-4 does not respond well or does not go well with the other faunal and floral proxy records. This is one thing which is very intriguing, which we need to investigate further. As I told you, because of the high biological productivity, OMZ, this basin, the Arabian Sea basin, is characterized by the intensity, the role and the carbon reservoir through denitrification and provide the primary control which in turn influences productivity and CO2 sequestration by the biological pump. Therefore, it is very imperative to investigate the mid-depth water circulation, ventilation and oxygen condition in the water column, particularly at the mid-water depth, expansion and contraction of the OMZ and the denitrification processes involved. OMZ, if you see that in the modern time, you have the intensified OMZ in the Arabian Sea, which has been shifted from the western side to the eastern side. And here we have taken the two cores, the SK17 and 131, as I told you, and we have also compared our records with the Western Arabian Sea and to address how the OMG intensification has varied and how it has influence on the carbonate chemistry, and as well as how the denitrification, it plays a role to change the denitrification intensity in the past. We have used the theropod records. Most of you must be aware that the theropods are the organic stable polymorph of the calcite. So it's a preservation and the dissolution. It depends on the carbonate ion, which is and the carbonate ion at the mid-water depth being the mesophilic inhabitat. So if you have the CO2 concentration more the CO2 column as well as aragonite composition depth or the aragonite the lysocline. What I would like to tell you that the preservation of these aragonitic theropods are related with the OMZ intensity. When you have the intensified OMZ, that means the ACD is shallower, then the aragonetic shells will be dissolved. That means that these total theropods which we can refer it the pteropod spike or the aragonite spikes. These spikes, if you compare with the Greenland ice core records, it matches very well during the stadial time, cold stadial times. You have the pteropod spikes, but during the interstadial or the warmer time, that the pteropods are much dissolved. That means that during the stadial times, you have the weak OMZ, but during the interstadial times, you have very strong OMG and very shallow ACD. In order to strengthen our interpretation, we have also used that the shells, the ultrastructure of the shell of the pteropods. If you see that that fresh pteropod shell is completely the transparent like this, and when there is a dissolution effect, first it becomes to the white, and if the dissolution is intensified, then the shells of the pteropods gets started dissolving. That means here also we have taken that the transparent the pteropod cells means transparent shells of the pteropods indicate the least dissolution. So all these pteropod spikes, most of the pteropod spikes, where you have to increase the number of the transparent pteropod cells. Overall, what I want to emphasize here, that these pteropods are the best proxy to find out the changes in the OMZ, in the ACD fluctuation. Then we try to study whether the change in the OMZ is controlled by the primary productivity induced by the monsoon variation. We have compared these pteropod spikes with the organic carbon content, and then with the nitrogen isotope, which indicates the denitrification, water column denitrification process. And we find that there is the relationship between the relationship between the pattern of the organic carbon variation and the pteropod. Wherever you have the low organic carbon content, you have the high pteropod shell concentration. That means that these pteropod spikes are really influenced by the primary productivity. Again, then we compare this, the second process which could be involved, that is the deep water circulation, whether it influences at the mid-water depth, whether the global circulation, it changes through time, and that ventilates the water column. For that, we have used the novel proxies like one pteropod species, that is the Styliolus. So here we have counted this. I present in the Arabian Sea is absent except in Western Arabian Sea, because this is the mesopelagic species which flourishes in high oxygen condition. So we have compared this Styliolus. We have compared with the Menardii. Menardii, in our recent papers, what we have established that the Menardii is a thermocline species, and it declines when you have the oxygenated water at the thermocline. We see a very matching pattern between Styliolus and Menardii and the pteropod spikes, and that is related Western Arabian Sea, the benthic isotope record. Benthic isotope records has the Antarctic intermediate water signature, the heavier isotope of the Antarctic intermediate water. When we compare that, what we found that wherever you have the intensification of the intermediate water, bringing more oxygenated water at the core site, then you have increase in the number of the stylurula subula, very low Menardii, and then you have the increase in the number of the theropod spikes. We have also used another very well established proxy for the ventilation, just to study the ventilation condition in the water column. We have seen changes in the C14 edges of the benthic and the plentic. You can find it here very well, that wherever you have the theropod spikes, you see that the difference of the benthic and plentic C14 edges is low. But when you have the more dissolution, you have this difference increases up to the 3000. That means you have old water is sitting there. That means that the intermediate water are the thermocline water at the core sites. It is very much influenced by the ventilation condition induced by the intermediate water circulation. And when you have the high intensification of the Antarctic intermediate water inflow to the Arabian Sea, you have more, the theropods you have the theropod spikes indicating the weak oxygen minimum zone intensity. When you compare, of course, there are very few records of the theropods from the Arabian Sea, but we have the record from offshore Pakistan and then offshore Somalia, and we compare this across the basin, the theropod records, ultimately compared with the benthic isotope records, ultimately compared with the Greenland isotope. And what we see here, that these theropod spikes across the basin, it matches very well. That means across the basin, the oxygen minimum zone fluctuated synchronously, except this period is very, very intriguing. You can notice here that at the deeper side, this side comes from 1200 meter water depth, where the increase in the theropod spikes, it leads to the other core records which comes from the shallow area. That means there is the initiation of the intensification of the Antarctic intermediate water is started earlier than what we have already seen, from the silo core. And this has been studied by Roman et al. 2014, and he termed it as a tunneling effect. What does it mean? That I could explain it in that way, that Antarctic intermediate water intensification started much earlier than the 17.5 K, and then more intensified and expanded vertically, influencing all the silo cores which you see here. Now, the last part is that as the Arabian Sea has one of the strongest perennial OMZ in the world oceans, once the oxygen level falls, below 1 micromole, the nitrate, NO3 is used as oxidizing agent for the organic matter respiration, resulting the denitrification, which releases the nitrous oxide and the nitrogen. The denitrification reduces ocean nitrate inventory, limiting nutrient that would result in a reducing productivity, lower drawdown of CO2, and that is the positive feedback to the global warming. So this is very important in the current scenario of the global warming, just to study how this has changed in the past at the millennial scale. And the nitrogen isotope in the sediments is very well established proxy. Just to record the water column denitrification, and what we have seen from the off Somali, off Oman, and off Pakistan margin, you have you see changes at the millennial scale, but there is a difference. You can find that 6 degree, this I have taken as a threshold, which we could see that more than the 6 per mil, we can say that this is the intensification of the denitrification. So what you see here, that off Pakistan margin, you have in the late Holocene, you have the high intensification of the denitrification, and as well as during the warmer period of the boiling LRR. But in the offshore Goa, you had the millennial scale oscillations during the LGM period, during the boiling LRR, during the early Holocene, and then there is increase in the intensification of the denitrification in the late Holocene. So, as I told you, there is intimate the oxygen minimum zone is related with the primary productivity, and this is also related with the how it has changed in the past. But the Holocene, the change in the Holocene is quite interesting, because the sea level change has also a major impact, because of the rise of the sea level, during the Holocene period, the Persian Gulf water and the Red Sea water, it flows in the northeastern Arabian Sea, and then because of high inflow of the Persian Gulf water, which is very low oxygen content it has, then you can find the during the late Holocene the intensification of the denitrification. If you compare that the nitrogen isotope record of the northern Arabian Sea and eastern and the western Arabian Sea, here you can find that the nitrogen denitrification is both the pattern of the denitrification in the both sides of the north very well. It goes very well. But here in the eastern Arabian Sea and western Arabian Sea, what you could see here during the early Holocene, you have the high denitrification in the western part, and the reason is quite obvious, that in the western part, what you see here, high biological productivity due to the high massive upwelling during the early Holocene. But during the LGM time, you have the high denitrification in the eastern Arabian Sea, because you have here, as you have seen in my earlier slides, that during the LGM time, you see the high productivity because of the high intensification of the winter monsoon induced vertical mixing in resulting the high productivity. Now I am coming to the benthic environmental conditions. That the benthic environment conditions, the benthic foraminifera we have used as a proxy because they are very, very sensitive to the oxygen condition and the organic carbon flux, which comes from the top, which comes from the photic zone, and these benthic foraminifera they show they have species specific preferences for their microhabitats because of their adapting capabilities, and they show the different groups of the microhabitat, different kinds of the microhabitat preferences, which we could group the epifaunal and infaunal groups, and these epifaunal and infaunal they show a particular kind of their shape. So related it is related with the oxygen condition. It is related with the oxygen condition at the seafloor. So what we have seen here, that the changes in the morphogroup categories where the plano-convex increase in the plano-convex test, showing the high oxygen preferences at the seafloor, and then it goes parallel with the changes in the Greenland ice core records. That means a change in the oxygen condition, and it has the signature of global climatic events. Now, if you see that at the end of the day, we would like to see the entire water column structure. So here we try to compare the pelagic system, what is happening in the surface, with the benthic environmental system, and then intermediate water condition at the mid condition. What is this? The benthic environment has signature of the Antarctic intermediate water, because these sites are coming from the oxygen minimum zone. So the benthic signatures have the benthic environment means it's more related with the ventilation condition, and then the pelagic signatures, it is more related with the atmospheric circulation, and then this is the OMG, where you have the surface ozone circulation, that is the atmospheric circulation, and the intermediate water circulation. So at the end of the day, there is close coupling between the pelagic and the benthic environment, and they are linked through the atmosphere and the oceanic circulation system. We have also compared, because once you have the high intensification of the OMG, you have high denitrification, and and once you have the denitrification, you have the release of more the nitrous oxide. So you could see a very beautiful correlation between the denitrification because the nitrous oxide. At the end, we have also compared our Indian margin high oxygen taxa, benthic foramen, high oxygen benthic forum taxa with the Bay of Bengal sites, The Bay of Bengal, our core site, it comes from more than 3,000 meter depth, where it is obvious that Antarctic intermediate water is not going to have any influence on that. What we could see here, opposite the relationship during the Holocene time. You have the increased abundances of the high oxic benthic taxa during the Holocene time, and here during the glacial and deglacial time, you have very low high oxygen taxa, or that is replaced by the low oxygen taxa, which is opposite to our the Indian margin side. This could be very well explained that here in the Bay of Bengal side, you have the influence of the North Atlantic deep water, and this has been already studied recently by the Ma and others. So with this, I thank you all. I acknowledge my students that who were behind to all these kinds of the very tedious work of generating the micropaleontological data. I also thank my collaborators, the Dick Kroon, the Pallavi Anand, and Holborn, and IODP, the chief scientist, and many others, who could help me to generate this kind of interesting data. Thank you so much.
Thank you. Now let's move on to some of the questions. We already have one here by Ramanand Yadav. Would you like to ask your question out loud, or would you like me to read it out for you? I'll give you a moment. What they're asking is, let's see, sir, can we have more mysteries in terms of winter monsoon, the OMZ variability, and intermediate circulation beyond the millennial timescale, say for million-year timescales from the Eastern Arabian Sea at intermediate water depth?
Yes, sure. Yes, that what you see on the millennial scale, time scale variability of the OMZ, you could also see, at the changes in the millennials of the time. You might have seen that, from the 355 expedition record, Manish Tiwari and his group has investigated in detail, and they have recently a good publication showing changes in the OMG, on the millennial time scale, in the last, in the last 3 million years, in fact, they have produced the denitrification record and the OMG record.
Okay, so let's move on to the next question by Prosenjit Ghosh. Did you want to read out your own question, or would you like me to read it out for you?
Yes, Prosenjit Ghosh.
Oh, I think I see. Prosenjit, did you want to ask your question?
The connectivity is really poor. Hello?
Oh,
Okay, hello? Can you hear me?
Yes.
Yeah, so great talk.
Yes,
I enjoyed. Yes. So now
Thank you.
There are questions like what happens to the thermocline depth when you think of disturbances like western cyclonic disturbances or tropical cyclone, which also happens during winter time? And is there something relevant when you think of a paleo record?
Yes. But now here, the question is that, Dr. Bose, that we are talking on the millennial scale, time scale. So that, okay, when you have the very frequent occurrences of the cyclone, the cyclone, yes, it is going to it is going to have the impact on the thermocline, but it's very tricky that whether you could really pinpoint you know, at the millennial scale, time scale, that you know, is there any influence related with the cyclone? Of course, if you are going to have a very high resolution kind of study, you know, at the annual time scale, or even the seasonal time scale, for that you need to have the coral records, etc. Or you can have the coral, or you can have the warp records. Warp record, if you have, then you could pinpoint that how it could affect, you know, the western cyclonic disturbances, that the thermocline. Yes, of course, it affects. There is no doubt in that.
Okay, thank you.
The next question is by Jeet Majumdar. Would you like to ask your question?
Hello.
Good,
Hello.
we can hear you.
Yeah, thank you. My question is that specifically from the Eastern Arabian Sea, what are the, I mean, most suitable proxies in case of foraminifera or pteropod, which are very good for inferring northeast monsoon?
Jeet, if you were working on the northeastern Arabian Sea region, you know, you might have seen the paper by Schulz et al. Maybe in 2000 in the Geological Society, 2002 in Geological Society London. It was published by Schulz et al. Where they have compared Globigerina falconensis with the Globigerina boloides, and there since they have studied the sediment flux record, so they have established this proxy. In fact, so Globigerina falconensis, it could be the indicator. But now you see, it depends on the area where you are working. Okay. And
Okay.
You need to have the sediment flux records. Okay. But if you are working in the northeastern part of the Arabian Sea, I believe Globigerina falconensis is the best proxy for the northeast winter monsoon.
Okay, sir. Thank you, sir.
Are you convinced?
Yes, sir.
Are you convinced?
Yes, sir.
The next question is by Biseswar. Would you like to ask your question? Okay, so their question is asking the synchronous variations in productivity in the OMZ water column. Is it just coincidence in the Eastern Arabian Sea, or is it a well-connected link of oceanic processes? So.
Any oceanic process, it cannot be coincidence. It cannot be coincidence. How it could be coincidence? You know, you see, we have proxies. We have proxies to record that, okay, there have been the synchronous breakdown of the productivity. And this is what we infer based on our proxy records. It cannot be coincidence.
Okay. And then, so if anybody else has any other questions, please type them quickly here in the chat. And while we're waiting, I have two quick questions. So it just touches on a little bit of what you mentioned earlier with the pteropods, because I found that as a very interesting proxy. I'm not as familiar with pteropods. And you mentioned that there are records maybe as old as 3 million years. I mean, how old do you think pteropod preservation would be around for? Because it seems like a very nice proxy for the oxygen minimum zones that you're talking about.
Yeah, it's a really very good question, and these pteropods, since they're very susceptible to the dissolution, so it's a preservation is one very tricky point. So generally it cannot be beyond the Pleistocene. Beyond the Pleistocene, I don't think that it would be much more useful. So since the Pleistocene, I think we have the good preservation of the pteropods. Then again, it also depends that how much organic carbon is there in the sediment. If you have more organic carbon in the sediment, then you have the more the respiration and oxidation, increasing the CO2 and dissolving the pteropod shell.
Yeah.
So in the continental margin, in the younger sediments, the pteropods, it could be the good proxy.
Okay, so when you have them and the preservation is good, they're very good. Okay, and then we'll hold off on my other short question. Oh, because we have more questions here, which I think we'll ask these two, and then I think that'll be enough for today. So we have Madhav Mishra, who has a question on denitrification. Would you like to read out your question? So they're asking that what is the main reason of much of the denitrification in the Arabian Sea? And is it the tipping factor for reduction in productivity of that part of the oceanic realm?
Excellent. Yes, it could be. In fact, the Arabian Sea denitrification, it has a big role, in fact. And that I have explained you, the more denitrification, it changes the carbon inventory, and then you have the reduction of the productivity. So yes, there is no doubt in that.
And then the last question is by Arun Dam. Would you like to read out your question? What they're asking is the productivity through coccoliths was mentioned in a graph where you mentioned about the dinoflagellates. Could you tell if you have considered all the coccolith species or some particular species for this, since both planktonic forams and nanos are in the pelagic part of the ocean? So it should show the same trend, or it would be expected to show the same trend.
Yeah, Dr. Arindam, this coccolithophore data was generated by my collaborator Tabarkas, and if I remember correctly, he did not use the whole population. He has used the selected species.
Let's see. There's a clarification for one of the questions earlier, having to do with the coincidental processes or the oceanic processes here in the chat. So I'll just read this comment out here. So they're clarifying that what they meant to ask was whether the variations recorded in the Eastern Arabian Sea are only found in that area, or are there any other similar findings from other sites from other sites as well, irrespective of the presence of such an intense perennial oxygen minimum zone in the water and column structure?
Yes, this is here you are right. In fact, that what you mean. So now I understand that. Yes, we have not found any other reason showing this kind of the synchronous, the collapse of the productivity. Yes, yes, you are right. So this is what that we need to look further, that whether there are some other areas also, so where we have this kind of the synchronous, the collapse of the productivity, where we could relate it with the reduction in the southwest and northeast monsoon both. Yes, you are right.
Okay, and so with that, I just have one short, quick question. Is that a giant planktonic foram behind you? Do you have a big model of a plankton behind you?
This is model. This is model. Yes, yes, yes. Rumor. Yes, yes.
Okay.
It is. We have a model,
I think that we've asked enough questions for today. So if you have any other questions to Dr. Singh, please feel free to send him a message. And so thank you all for attending today. And so I encourage all of you to attend next week along on our Schedule A session for Cow Tarumalai on the 29th. And if you are interested in subscribing to our email list, such as getting these a Zoom recording of this, if you don't want to watch the YouTube channel, please make sure to send me an email or Liviu or Peter an email. And you can see, of course, all the schedules for everything on our website. And so with that, I would like to thank Dr. Singh again for a very wonderful talk, talking about all the different complicated oceanographic and hydrographic processes that are happening in the Arabian Sea. And I hope that all of you have a very nice rest of your day. So thank you very much.
Thank you, Tara. Thank you so much. Thank you so much.